Hello everyone, I'm Jessica Kanchella and I'll be explaining you guys the solving of the 7th question in homework 7. So let's have a look at the question. It is given that z of t is equal to n1t into cos omega t plus theta plus n2t into sin omega ct plus theta, where theta is uniformly distributed n0 and 2 pi. Also, it is given that n1t and n2t are WSS, which is white and stationary, and n1t and n2t and theta are all independent. Here we are asked to find the expected value of z of t. Therefore, let's look at the solving of this question. Okay, so expected value of z of t, we are given the equation for z of t, which is the question, that is this part. Now we will be substituting that here. We will get expected value of n1t cos omega ct plus theta plus n2t into sin omega ct plus theta. We can, since all of them are independent, we can just write them as e of n1t, expected value of n1t into expected value of cos omega ct plus theta plus expected value of n2t into expected value of sin omega ct plus theta. Now it is given that n1t and n2t are whites and stationary, which implies that expected value of n1t is equal to eta 1 and the expected value of n2t is equal to eta 2. If we substitute these values, we will be getting this equation, which is eta 1 into 1 by 2 pi integral cos omega ct plus theta d theta over the limit 0 to 2 pi, and eta 2 into 1 by 2 pi integral sin omega ct plus theta d theta over the limit 0 to 2 pi. We know that this value and this value is equal to 0, therefore we will get eta 1 into 0 plus eta 2 into 0, which is equal to 0. Therefore, the expected value of z of t is equal to 0. In the second part, we are asked to find the value of Rc of t1, t2, and are also asked to find out if z of t is WSS, which is whites and stationary. Now, this is a condition of autocorrelation. Now, we can write Rc of t1 and t2 is equal to expected value of zt1 into expected value of zt2. We know the value of z of t, which is given in the question, that is this equation. Now we will be substituting that same for t value t1 and t2. Therefore we will get expected value of n1 t1 cos wct1 plus theta is n2 into t1 into sin omega ct plus theta into n2 t2 cos omega ct2 plus theta plus n2 t2 into sin omega ct plus theta. If we multiply these terms, we will be getting all of this, that is n1 t1 into cos omega ct1 plus theta into n1 t2 into cos omega ct2 plus theta plus expected value of n1 t1 cos omega c theta into n2 t2 into sin omega ct plus theta plus expected value of n2 t1 into sin omega ct1 plus theta into n1 t2 into cos omega ct2 plus theta plus expected value of n2 t1 sin omega ct1 plus theta into n2 t2 into sin omega ct2 plus theta. Now if we simplify all of this, we will be getting this equation. We will get this equation in the form of tau. Therefore it is equal to 1 by 2 into r in 1 tau plus r into tau into cos omega c tau. With all of this is equal to rc of tau. Therefore z of t is equal to whites and stationary. In the third part, we are asked to find rc of 0 if z of t is whites and stationary. Therefore here we calculated that rc of tau. In place of tau, let's substitute the value equal to 0. Therefore it will be 1 by 2 into 0 into r in 1 of 0 plus r in 2 of 0, which is equal to 1 by 2 into e of n1 square t plus e of n2 square t. Therefore this is the solving for the 7th question.